Hey everyone, welcome back. Today we're going to look at special triangles. So what is the value of sine of 15, cos of 30, tan of 45? So from special triangles and SOHCAHTOA, we're able to obtain exact trig values for certain angles. So let's get started. Here we have an isosceles triangle where the two angles are 45 like that because we have two of the same sides as such. And so what we're going to do is find out what that a value is. So we have 1 squared equals a squared plus a squared like that. This gives 2a squared, divide by 2 on both sides, square root both sides, and so a is 1 over root 2. We're going to rationalize the denominator, so times root 2 over root 2, and so our a value is root 2 over 2. And so this is one of our special triangles. Root 2 over 2, root 2 over 2, 1, and the angles here are 45 on a 90-degree triangle. And because it's 90 degrees, we can use SOHCAHTOA. So here we have sine 45 equals opposite over hypotenuse, so root over 2 over 1, which gives root 2 over 2. Cosine of 45. We have adjacent over hypotenuse, so root 2 over 2 divided by 1, which gives root 2 over 2. So tan 45, this is opposite over adjacent, so root 2 over 2 divided by root 2 over 2 equals 1. And so here we have some exact trig values. Okay, another triangle we're going to look at. Here we have an equilateral triangle, so the angles are 60 here like this. What we're going to do is put a line right down the middle at 90 degrees, cutting this in half. So this is 30 degrees, and here instead of 1, this becomes a half like that. So you have 1, a half. Now we've got to find out what that a value is. And so we're going to use the Pythagoras Theorem. Half squared plus a squared equals 1 squared. So we have a quarter plus a squared equals 1. Minus 1 quarter to both sides, so a squared equals 3 over 4. Square root both sides, and we get root 3 over 2 like that. And so this is our special triangle. And so from this triangle, sine of 30, so we're looking up here, sine of 30, opposite over hypotenuse, so opposite a half over 1. All right, and so a half over 1 is a half. Cosine of theta, adjacent versus hypotenuse, so adjacent over hypotenuse, so root 3 over 2 divided by 1, which gives root 3 over 2 like that. And then now we have tan of 30, opposite over adjacent, so a half divided by root 3 over 2. This gives a half times 2 over root 3. 2's cancel out, 1 over root 3 is left. Rationalize the denominator, root 3 over root 3, and so this gives root 3 over 3 as our value of tan 30. Okay, and so we can still use that same triangle, except instead of looking at it from the 30 perspective, we're going to look at the 60 degrees perspective. So sine of 60 is opposite over hypotenuse, so root 3 over 2 divided by 1, which is root 3 over 2. Cos of 60, adjacent over hypotenuse, so half over 1, which gives a half. And then tan of 60 is opposite over adjacent, so root 3 over 2 divided by a half, like that, times the reciprocal, 2 over 2 cancels, and so tan of 60 is root 3. Okay, and so these are the similar triangles we use, this one and this one, like that. If you want, you can use these triangles, right? If you're going times root 2 to all three sides, you get this triangle instead. Or if you go times 2 to all the sides, you get this triangle instead. And so whichever one you want to remember to use is no problem. They both give the same values for our trig ratios. And that's it. It's that easy. I'll see you guys in the next lesson.